Take a sphere of any size and drill a hole directly through the middle. Let the diameter of the hole be the exact size such that the remaining part of the sphere has a height of 2 inches. The remaining solid will look just like a napkin ring. Believe it or not, the volume of the napkin ring does not depend on the size of the original sphere. We can prove this by recognizing the shape as a solid of revolution. That means it can be generated by taking its two-dimensional cross-section, specifically the upper positive half, and revolving it around the x-axis. This is the height of the solid after drilling the hole. So let's say it's running from negative h/2 to positive h/2. The volume of a solid of revolution is defined by this integral formula, where big F of x is the upper boundary of the region, and little f of x is the lower boundary. The upper boundary is the arc of a circle centered at the origin, described by the equation x squared plus y squared equals r squared. If we solve for y, we get plus or minus the square root of r squared minus x squared. Of course, this is positive since the region is above the x-axis. Again, this is the upper boundary, so we can let it be big F of x. The lower boundary is simply a horizontal line with a constant y value. If this is the radius of the circle, and this is h/2, we can find y by recognizing this as a right triangle and using the Pythagorean theorem to get this. This is the lower boundary, or little f of x. Now let's plug these functions into the integral formula. We can clean this up by squaring the roots and distributing the negative, then combining like terms. And let's plug in the limits as well. This region is symmetric to the y-axis. Instead of going from negative h/2 to positive h/2, let's go from 0 to h/2. Then all we have to do is double the volume. Now it's time to integrate. The antiderivative of h squared over 4 is h squared over 4 times x. And the antiderivative of minus x squared is minus x cubed over 3. And we are evaluating from 0 to h/2. Plugging in 0 would just give us 0, so we really only need to evaluate at h/2. Clean it up, and we get pi h cubed over 6. So this is the formula we use to find the volume of our solid of revolution. Notice how the radius of the original sphere is not required. All we need to know is the height of the napkin ring, which in this case is 2 inches. Even if we started with a ball the size of the Earth, as long as the height of the ring is 2 inches, it would still have the same volume. In this case, about 4.2 cubic inches. If you enjoy solids of revolution and you want to learn more, check out my video where I explain how to find the volume of a donut. And don't forget to like and subscribe. Thank you all for watching and have a pleasant day.
Shh.